Here are the law of exponents and why they work. First, the product rule. If we're multiplying two numbers with the same base, we add the exponents. But why? Exponents mean repeated multiplication, so a to the m means m amount of a's multiplied by each other, and a to the n means n amount of a's multiplied by each other. So how many a's are being multiplied by each other? Well, m plus n. And if you want a more concrete example, y to the fifth times y squared, we have 5y's and 2y's. How many y's are being multiplied by each other? 7, or 5 plus 2. Now for quotient rule, we subtract the exponents. But why? There are going to be terms that can be simplified to 1, and subtracting helps us with this process. In both of these examples, we see that there are 2y in the numerator and the denominator, and subtracting helps us see what terms are remaining after we said that y over y equals 1, provided that y isn't 0. And I will explain why this part is true in a little bit. Now the power rule. If we have a power to a power, we multiply the exponents. But why? Remember that exponents mean repeated multiplication, so this outside exponent says to repeat what's on the inside that many times. And we know from the product rule that we add these exponents. Or if you really wanted to, you can expand it like this. Now, power of a product rule. We raise each term on the inside to the exponent on the outside. But why? All we're doing is just moving things around. So if we have m amount of a b's, let's move the a's to one side, b's to the other, and we have m amount of a's multiplied to each other, and m amount of b's multiplied to each other. And if you want a concrete example, here it is. Now, power of a fraction rule is basically the same thing as power of a product rule. The only difference is to replace b from the previous example with 1 over b, and you get the same thing. Now, the zero exponent rule. Any non-zero raised to the 0 power equals 1. But why? There are a couple ways that we can explain this. The first one being the quotient rule, where we know to subtract the exponents, m minus m equals 0. But we know that all of these create 1, so a to the 0 equals 1. The second way that this makes sense is following a pattern. So what pattern do you notice? We see that as we're decreasing the exponent by 1, we're dividing by a. So 1 minus 1 is 0, a divided by a is 1. And if we continue this pattern, it helps explain why the negative exponent rule makes sense. For example, a to the negative 3 is equal to 1 over a cubed. So in a lot of these, we use the idea that exponents mean repeated multiplication. So if you remember that, your confidence in exponents will go exponentially higher. Sorry for the bad joke.